Today we're going to talk about Marlin firmware and the way to install software on a couple of different configurations. There will be several others that I don't cover during this tutorial, but those are pretty simple to figure out, and I have videos floating around all of my playlists where you can look into those. So what I'm going to talk about first is up here. There are three versions that you see of Marlin. You have the oldest release, which is 1.0.2-2, and that's a fixed build that was originally released. Then you have the previous release, which is 1.1.9.1. That's usually used for 8-bit processors just like the other one. And an 8-bit processor would be like the RAMPS configuration with the 2560 chipset. At the very top, you have the latest release, which covers 8-bit processors as well as 32-bit processors, and that's 2.0.9. In order to actually download it, you would click on the downloads folder right here and be able to pull it down. Now, they do talk about something over here for view download. This is where example files would be found for configurations. If you were to pull this down, it would give you example files for what your possible configuration would be for the printer that you're using. Now, there's an important thing to realize about this in that these are example configurations. They're not your configuration. So a lot of the tutorials that I've made will cover the intricacies of these points and ways to actually install. So remember to like and subscribe because that's most important to understanding other things that I'll be talking about in the past as well as the future. So there is another thing down here called release notes, and that says what the current build was, when it was released, and it tells you what's included inside it. So there's new features. So as you can see, there are a lot of new features because now you can do more than 6 axes for your actual printer. There's also new controllers, new boards. There's how to optimize things they've changed, fixes to boards and pins, and various other things. There's also previous releases down here where you can also find the source code for them. So these are good resources. There is another couple of resources. There's help over here to explain other functionality that works with Marlin. And then there's reporting issues. As you can see, there's lots of issues that have been reported, and it's really easy to search. For instance, if you have a BL Touch, you can say BL Touch, and then you can actually search on this, and it'll talk about the current issues. They also have other issues that you can resolve with their Facebook page or their Discord page, or you can just ask somebody you know. So now that I've covered that and I've already downloaded and extracted this, I'm going to show you VS Code. Inside VS Code, I've already installed it, and I've made a tutorial on how to explain installing it. So VS Code is really simple to actually install, and I'll include a link in the upper right hand corner so that you can figure out how to do that. It also includes Platform IO as an extension, which I cover on how to install. So what I want to show you first is how to open this. So I'm going to click on Explorer, Open Folder. I'm going to go to my Downloads folder, my first Marlin folder that I extracted, then the folder within there. And as you can see, this is where we're going to say Select Folder. Now, I have it opened to the point where it has the configuration file, but I want to show you first the platform io.ini. Right now, the default environment for this is going to be the Mega 2560 chipset and the ramps board that's plugged into it. So I'm going to show you that real quick. So if I go over to my workbench here, I have the ramps installed and I have the USB attached. So now that we know that we're actually connected to it, we can double check that a couple of ways. So I'm going to go over to my desktop real quick and I'm going to type Device Manager just to confirm where it's actually residing. So down here you can see ports, and then you see the Mega 2560 chipset and COM port 8. That will be important in a moment. But to actually set this up, we're going to go to configuration.h, and I searched on motherboard to verify what our board was. And I'll go into more depth in that in a second. And our serial port in this case will be 0 for the 8-bit processor. So to actually set this up for a build, what we need to do is first do a clean, which is a good habit. Then you're going to click either the checkbox, which is build all, that's a series of compiles that take place, or you're going to do build all, and then you're going to upload. So we're going to choose this option for this moment. So this will build, and keep in mind that while this is building, it may take a few moments. If you see a failure, try building a second time, because on occasion things will build out of order. Now what you can see here is that it's actually reading the device and now writing to it. So this is actually going to load our firmware and confirm it for us now. So it said successful. So to confirm that, what I can do is I can actually go over to Pronterface that I have over here on my desktop, open this up, and inside Pronterface, currently you see that there's a COM port 8, which we earlier confirmed was the actual COM port. If it's not, you can always highlight it and change the number. So we're going to click Connect, and as you can see, it's checking the printer to see what the output is in this case. So if you type M119, it'll tell you the status of your end stops. Now they all say triggered and there's no end stop connected. That's because there's no trigger occurring. If there were an end stop, it would probably say open depending on the end stop. Now that we've covered that, I'm going to actually try another board. And in this case, I'm going to try the SKR version 1.4 Turbo by Big Tree Tech. So I'm going to go over to my desktop for a second and show you what's occurring. So on here, I'm going to disconnect this and I'm going to connect it over to the SKR. Now, as your SKR comes to you as a default configuration, you'll realize that there's a couple of things that don't work, being the USB without power from a power supply. So on this, they actually have a switch where you can remove the jumper and place this jumper for the USB connection to power your board. Do not use it for your stepper drivers because it may cause issues. Always leave it on direct power when you do that. So as you can see now, it is powered up, and what we can do is we can either program this through the USB cord, or we can or we can actually do it through a device that will take the SD card. So the SD card is located right here and pops out, and you can pop it into here and then your computer and load it. So I'll show you that in a few moments on a different board, but this one will actually load via the USB. So let's go back over to VS Code, and inside VS Code, it's going to be a little different this time. So if we click on platformio.ini, you can see that it's the Mega 2560 chipset that we're using for the default environment. And then you see over here that it says INI/, and then it's got a different chipset for each one. So in this case, they've organized it slightly different with this version of Marlin being 2.0.9, and they also started doing this in 2.0.8. So if you click on the INI folder, it'll show you each one of the configurations. In this case, the Mega 2560 is in the AVR folder for the 8-bit processor. So to configure this in this case, we're going to click on Source, Core, Boards.h. And inside here, we're going to search on SKR underscore V1, and that'll bring us to the SKR configurations for our particular board. In this case, we're using the Turbo. So I'm going to right click on this and copy it. Then I'm going to minimize core and source, and I'm going to go over to configuration.h. Now we're going to search on the actual motherboard type, which is right here, and paste our new motherboard type. Now this obviously loads differently, and you can obviously modify the speed at which you communicate with your board up above, but this is a pretty good configuration speed. But over here, for the first serial port, you want to say it's -1 in this case. This will allow it to load directly. Now, the next thing you have to keep in mind when actually building is that the previous build is right here, and we want to change that because ours is no longer hex. This is actually the software that's being loaded. Hex means that the numbering is from 0 to F for the letters that it specifies, and that breaks down into binary numbers. So what we need to do is click the clean button, which will clean out this folder, and then we can do our build. So we're going to try to do a build like an upload again. So I'm going to click on this, and as you can see, it's failing initially. That's because we have some type of issue occurring. So the issue that it says right here is something about LPC 1769. What that means is that if you go over to platformio.ini, you can see that we're on the Mega 2560, so it will not work. So what you need to do is click on the INI folder, and you have to remember that when we're in the source folder for core boards.h, it said that the actual board type that we're working with is the LPC 1769. So if you go up here and you look for that chipset, you see LPC 176X.ini. So click on that, and as you can see, it's got the two different processors. So in this case, we're working with the LPC 1769. So we're going to click on the LPC 1769 for our chipset, right click, and copy. Then I'm going to close this, and I'm going to go back over to platformio.ini, highlight the default environment, and paste it. Then I'm going to do a clean again, and then I'm going to do an upload build again. So I'm going to click on that. This may take a few moments. If it fails the first time, remember to compile a second time. If it doesn't work the second time, find the very first error that you encountered and then fix that one. So right now it's still not working. So let's see what's going on here. So I'm going to do a clean. I'm going to close this out, and then I'm going to try upload. So it looks like it's building now. So it looks like we resolved the current issue that we saw, and all we had to do was do a clean and rebuild. So this may take a moment to actually build, and once it's complete, we'll actually check to see if it worked. So in this case, what you can do is click on your file browser, and this creates a drive for us. You see firmware.bin. This is what we just built. Before that, there was a previous load 2 days ago that says firmware.cur. and it's in all capital letters, which means that's the current build that took place. And for those that are concerned about the type of file, yes, it does say it's a cursor type file, but it's actually a binary file. They just rename it as a shorthand. So if you wanted to use this file again, you could rename it to firmware.bin in lowercase and use it again. But in this case, what we're going to do is actually load it. So I'll show you the method that I use on the workbench. So I'm going to unplug it, then I'm going to plug it back in. This may take a few moments to load. You may see some flashing lights on the board, but that ding gives away that it's actually working. So if we go back over to the desktop on the computer and we click over to the D drive, you can see it's firmware.cur and it has today's date and when we compiled. So that is the build that we just loaded. Now you can also load this via a USB conversion stick with the SD drive. So I'll show you that now with another board. And this should make some of the examples pretty clear. So if we go over to the board now, I'm going to unplug the USB for a moment. And the load will not work the same if we do this for this particular board. So what we need to do is pop out the drive, and this is an SKR Pro version 1.2, and place it in our SD card reader here. So once it's in there, we'll plug this into our computer. And on our computer, we can see what's going on. So on our computer, we'll go back over to our folders. We'll find the E drive. And as you can see, there's two files on here right now. There's firmware.cur, and then there's a G-code file. The G-code file is actually a printer file. So we're going to go back over to VS Code. We're going to do a clean. And in this case, the process is going to be slightly different. So I'm going to minimize everything up here for a second so you can see what I'm doing. And we're going to go over to the source folder, the core folder, boards.h. We're going to search on SKR_Pro. And as you can see, we have two different versions. So I'm going to copy the second one for 1.2. And then it says that the processor is an STM32, as well as it says it over here where it says STM32F. So that's going to be relevant in a second. So I'm going to minimize core and source. I'm going to go over to configuration.h. I'm going to paste our motherboard type in here. I'm going to leave alone the serial port because we're fine there. And then I'm going to go over to the INI folder because we're working currently with Platform IO, and that's not our processor now. So I'm going to search down through here and you'll see STM32F for some of the folders. And then there might be another number after that. So we're going to start with this one. And as you can see, it's not in here. So to verify where that actually is, we can go to source, core, boards.h, and it says STM32F. So we'll minimize this, and then there's a 4 after that, by the way. So we go into this folder, we find the STM32F4, and then we search on SKR_Pro, and that brings us to the actual chipset that we're working with. So that'll be our default environment. So now we'll go back to platformio.ini, right click, and paste it right here. So that's why these folders are important. Now they've added other folders to this that I haven't talked about. There's a docs folder that talks about certain things that you'll need to know about configurations and how commands work and other things. But for now, I'm not going to cover that. And then Docker is something that has to do with a build environment. And then there's like a configuration file, and they'll say where to go read for that information. But these are not super important things I want to cover with you right now. I just want to focus on this. So we cleaned out this folder. We set our platform io.ini and we set our configuration.h. So now, as you can see, we have our serial port that we set. Now there are multiple serial ports, so you could use them for your LCD display, or you can use them for your Wi-Fi, and you can set individual speeds. Now I don't want to go too much into that because I cover it in a lot of tutorials and tutorials that will be occurring in the future. So let's just do a build so you can see what's happening. In this case, I can't do upload, so I'm going to click the checkbox. Now the checkbox will build but will not upload. And you'll see the reason for that in a moment because it cannot directly connect in this case. So this is almost done completing its build. What we're going to need to do is keep an eye on the .pio folder and see if firmware.bin appears in here. So if it does appear in a moment, I'll show you the process for getting it over to your drive. So it looks like it's pretty close already there. It just popped. So if we go over here and we find firmware.bin and right click, and then we go to view or reveal in File Explorer, we can then right click again and say send to, and send it to our E drive. And now on our E drive, we actually have the firmware.bin. So we're going to go over to the workbench for a second. We're going to pop out the drive. We're then going to pop it into here. And the same jumper may apply for actual power, but I believe I have this set to USB. And once again, let me remind you that this should be on direct power when you're using the stepper motors. But seeing how we're not at the moment, and I'm just showing you how to load, I'm going to plug this in, and you should see a flashing light. That's it actually installing. So to verify that it actually worked, we can go over to Pronterface and verify what's going on. So inside Pronterface, we can try and connect, and obviously we have an issue. So once again, we can go to Device Manager and bring it up. And inside Device Manager, we can go and we can see what's actually occurring. So we have ports. The COM port 1 is default to a desktop computer, but then we have 13. So I'm going to minimize that. I'm going to change this to 13. And then I'm going to bring it up so you can see both the boards. So I'm going to click connect. And it says connecting printer is now online. Now obviously you can do the same thing with M119 to check to see if the actual steppers come up. And then if you want to use something like M503 for a G code, you can check to see what the status of your actual configuration is and how it relates to what you loaded. So if you like my tutorial, please press the like button and subscribe. And thank you for your time.